An important class of vector fields in physics and theory, conservative ones. The gradient of some function. Gradient, partial derivatives in each component. Let's start with integrating them over a curve. Parameterize, say over 0, 1. Parameterization in t. TDS, tangent vector, dt. Components x prime, y prime, z prime. Dot it with the gradient, and this is exactly the chain rule. So it's the integral of df dt, dt. Calc 1, fundamental theorem of calculus. F at the endpoints. F at the end minus f at the start. And for curves, one of the biggest applications we're seeing so far are boundaries of surfaces, so curves that are loops. So running around the outside of some surface, in particular the start point, is the end point. Well then if I integrate the gradient over that, it's 0. These kinds of line integrals are special enough we have a special symbol and a special name, a loop integral. Apply conservative vector fields to Stoke's theorem. So now we're going around the outside of some surface, doing a loop integral around the outside of a surface S. Stoke's theorem, that's the same as the curl over the interior. And that's 0. So the loop is the boundary of the surface. The surface is anything with that boundary. So I could kind of fill it in nicely, or it could go down. It doesn't matter. Any surface with that boundary, this is true. And in fact, if you just compute the curl of the gradient, you get 0. Let's run through it real quick just to see. IJK. I component, and I get the two mixed partials. J component, two mixed partials, and the K component, two mixed partials. All the mixed partials are the same, and so they cancel out. Lastly, onto the divergence theorem. This one is more useful for conservative fields because it actually measures something. Set up the integral. This is now a loop integral over a surface. So use the special symbol to indicate that it's a surface that encloses a solid. And n, of course, is the outer normal. The divergence of the gradient is used so often, it has a special name and a special symbol, the Laplacian. Or in physics, they'll use del dot or del squared. In any case, it's the del operator dotted with the gradient, and you get the sum of the second derivatives.